In 2024, a developer typically worked in isolation, copying code from a private chat tab into their local editor. Today, that workflow is being replaced by a shared environment where an AI agent debugs live incidents directly within the team's communication channel. This shift marks the end of the ephemeral, single-user conversational model that has defined the last few years of AI interaction. On June 23, 2026, Anthropic introduced Claude Tag, a technology that turns large language models into persistent, organization-level entities. Because these agents can now coordinate tasks and maintain memory across an entire workspace, teams that continue to rely on manual single-player workflows will find themselves unable to keep pace with the speed of autonomous engineering. This transition is so significant that it has forced traditional enterprise rivals to open their private ecosystems to Anthropic's technology. Salesforce is a prime example. Despite having its own internal AI platform and owning Slack, the company is now actively promoting Claude to its customers. The motivation is financial. Salesforce has committed over $300 million to Anthropic for token usage and holds a stake in the company. We see the same pattern at Microsoft. To protect its position in the enterprise market, Microsoft is integrating this autonomous architecture directly into Teams through a collaborative product line called Microsoft Cowork. These giants are cooperating with their competition because the move toward autonomous, channel-native agents breaks the traditional rules of software lock-in. First, multiplayer coordination. A single agent operates as a shared resource for the channel. Second, it accumulates knowledge from discussions, learning patterns to remove manual context resets. Third, ambient proactivity lets the agent scan for anomalies without waiting for human triggers. Finally, the agent uses an asynchronous execution model. It can take a complex prompt, decompose it into subtasks, and manage workflows that run in the background for several days. These four mechanics enable the AI to drive engineering tasks forward independently, rather than simply reacting to a user's latest command. This autonomy is built on the Model Context Protocol, or MCP. It acts as a universal abstraction layer, standardizing how models query external databases. The protocol uses a specific topology, an MCP host acting as runtime, a client that manages the link, and a server exposing data endpoints. Using these standardized endpoints, the model can discover and execute tools across an organization's entire infrastructure. This protocol provides the interface that allows a language model to physically operate the software tools and data repositories used in modern IT. Historically, loading full tool blueprints into memory caused rapid context saturation. To solve this, agents now write on-demand execution scripts inside a secure sandbox. This processes large queries locally, returning only the refined result back to the model's main context. Processing data within the sandbox lowers compute latency and saves token volume, which allows these agents to operate within a sustainable enterprise budget. However, this newfound autonomy creates new risks. If an ambient agent is not strictly governed, it can rapidly consume an entire organization's token budget, halting execution mid-flight during critical operations. There is also the danger of agents modifying live cloud infrastructure without a human-in-the-loop checkpoint to verify the action. We are also seeing the emergence of tool poisoning attacks, targeting remote protocol servers. In these attacks, malicious code is hidden inside a tool's metadata. When the agent queries the server, it follows the poisoned instructions, which could lead it to exfiltrate confidential files or execute unverified commands. As we grant AI the ability to execute code, the focus of enterprise security must shift from preventing human mistakes to securing the logic of autonomous agents. This shift is already visible in the industry. Currently, 65% of Anthropic's own product codebase is generated by its internal implementation of these agents. For software engineers, the daily focus is moving away from manual syntax execution. The core competency is now becoming a mix of system architecture, prompt engineering, and auditing the code the agent produces. Infrastructure teams are seeing a similar change. DevOps engineers are now responsible for building custom tool servers, while site reliability engineers must define the boundaries within which an ambient agent can remediate an incident. The practical advantage in this new environment will belong to the organizations and the engineers who master protocol standardization, context architecture, and agent governance.